So today we're going to graph some other rational functions. And boy, some of these are really wild, so we're going to have a lot of fun with this. But first we need a little bit more practice with limits. So if we take a look at these three limits here, and we'll start with the one on the top left. We want to know what's this limit as x approaches infinity. Well, notice that the powers, the exponents, are really the things that matter the most. So in this case, the quantity x to the fourth is getting bigger faster than the quantity x squared. So the numerator will always be larger than the denominator, which means that our fraction's value gets larger and larger and larger, meaning that it goes off to infinity. So this limit approaches infinity.
Literary, magazine, photo.
These people with all these announcements, crazy. So if you take a look at the one to the right now, again, I have a trinomial, but it's a 2x cubed over an x. That x cubed gets bigger faster than the x, so we go up to infinity. And even on the bottom, 28x to the fourth, 200x to the third, those are going to make my denominator really big really fast. But eventually, x to the fifth overtakes it. So what do you notice? I think that's what it even says down here. What do you notice? So I'm hoping that you notice that when the larger exponent is in the numerator, that the limit as x approaches infinity goes off to infinity. That's cool. Let's do a couple more. Let's take a look at some of these limits now. If we pay attention to those exponents, in this case on the left, the bottom is getting bigger faster than the top. When the bottom of a fraction is bigger than the top, and it keeps going larger and larger and larger, the fraction gets smaller and smaller and smaller. This limit is approaching 0. And it's the same with the one in the middle. The x squared is making that denominator larger and larger, which makes the value of the fraction smaller and smaller, and eventually it goes to 0. And it doesn't matter how big the coefficient is. 99 times x to the 25th, x to the 26th is going to be bigger. So this limit is going to equal 0 as well. I think you know what my question is. Tell me what you notice. So if you're taking the limit as x goes to infinity and the larger power, the larger exponent, is in the denominator, then that limit approaches 0. Just keeps getting smaller and smaller and smaller. So interesting things are going to be happening here then. Take a minute and think about those limits for a sec. So if you take a look at this first one, as x gets infinitely large, it's 3 times a big number divided by a big number. Well, those big numbers are going to cancel, and it's just going to be 3. Same idea here. As x gets really, 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 really large, the 3 on top and the negative 11 on the bottom do nothing. We're really just seeing what's going to happen with 7 over 4, or 7x and 4x. So those kind of go away. The x's, they're going to cancel each other out. This limit is just 7 over 4. Same idea with this one. The x cubes will eventually just cancel each other out. And our limit is going to be 2837 divided by 520. And let's make it negative. So again, we got another little rule here. What do you notice? I think what we're noticing is when the powers are when, I like to write the exponents. When the exponents are equal, that limit as x approaches infinity is equal to the ratio of the largest power. So the ratio is going to be 3 over 1, or just 3. 7 over 4. Negative 2837 over negative 520. What do you think about all that stuff? I hope you like it, because, dun 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 dun, oh no! Next class, I'm going to give you a quiz. And the quiz is just going to be find the value of the limits. And it'll be questions like these, questions like these, and questions like these. So your answers are going to either be infinity, 0, or the ratio of two numbers. Cool. Well, let's see how all that's going to be used. Because those limits tell us the end behaviors of the graph. That's what those limits are doing for us. So again, we're going to proceed the same way with some of these. Let's first find our vertical asymptotes and our horizontal asymptotes. Remember, the vertical asymptote occurs when the x value makes the fraction undefined. So if I think about like having x squared minus 9 equals 0, I'm going to get this is true at x equals positive or negative 3. So those are going to be my asymptotes. The horizontal asymptote is going to be that end behavior. What happens as x approaches infinity? Well, the powers are the same on top and bottom. So if we take a look at that limit, we're going to get y equals 1 for that. Because as x goes off to infinity, the negative 9 doesn't really matter. So it's x squared over x squared, which is just 1. Let's do our x and y intercept now. The x-intercept occurs where the y value is 0. The y value is 0 where the numerator is equal to 0. So it's where x squared is equal to 0. So the x-intercept is where the x value is 0. And we do the same for the y-intercept. The y-intercept is just where the x value is 0. So it becomes 0 squared over 0 squared minus 9. And that's just y equals 0. Now, what's going to help us here as well is a sign chart. So let's make a little graph of what the signs are doing. So I have a value at negative 3 and positive 3. Those are for our asymptotes. It looks like it crosses the x-axis at 0 as well, so we'll include that in there as well. And let's think about what these signs are doing. If I take a number less than negative 3, when I square it becomes positive. And on the bottom, when I square it, it's going to be positive and bigger than 9. So I'm going to end up getting a positive over a positive. So we're positive to the left of negative 3. Between negative 3 and 0, when I square it, I'm going to get a positive number. But when I square that number between negative 3 and 0, it's going to be less than 9. So I'm going to have a negative on the bottom. So between negative 3 and 0, I'm negative. Between 0 and 3, same idea. My numerator is going to be positive. My denominator, though, will be negative. So I'm going to be negative there. And once I get past 3, I'll be positive on top and positive on bottom. So I'm going to have a positive value there, too. Let's take a look at what this graph looks like. So I'm going to have some asymptotes at negative 3 and positive 3. I'm going to have a horizontal asymptote at y equals 1. And I've got an x and y intercept at the origin, 0, 0. My sign chart tells me that to the left of negative 3, I'm positive. So I'm going to be up in this area somewhere. But I have to follow the asymptotes. So I'm going to go something like that probably. And then between negative 3 and 0, I'm going to be negative, so I'm following this asymptote. But then I hit y equals 0, and to the right of y equals 0, I am still negative. So my graph is going to look like that. And then when I'm outside of 3, it is positive. It's behaving like an asymptote would. So it's doing that. That's what this graph looks like. Holy cow, that's wild. But wait, there's more. Let's do the same thing for this graph. If you want to pause the video and play on your own, you can. Give it a shot. Alrighty, so first of all, let's find our vertical asymptotes. Again, it's where the denominator equals 0, so it will be at plus or minus 2. The horizontal asymptote, that's going to be that limit as x approaches infinity. Now, my denominator's power is bigger than my numerator's, so this will go off to be y equals 0. Let's figure out our x-intercept now. The x-intercept is where y equals 0, so it's where the top equals 0. It's where x plus 3 equals 0. So our y-intercept is at negative, I'm sorry, our x-intercept is at negative 3. And if we take a look at our y-intercept, the y-intercept is where x equals 0. X equals 0, that's gone, that's gone. So the y value is going to be at negative 3/4. Let's make a sign chart for this. So I'm going to be here at negative 3, that's one of my intercepts. Negative 2 is an asymptote. Positive 2 is an asymptote. If we play the sign game here, to the left of negative 3, I'm going to have a negative divided by a positive. So that's going to be a negative value. Between negative 3 and negative 2, the numerator is going to be positive. My denominator is going to be positive as well. So I'm going to get a positive value there. Between negative 2 and positive 2, well, there's a 0. There's my y-intercept. I'm negative. And once I go outside of 2, positive on top, positive on the bottom, I'm going to be positive. So let's see what this graph is going to appear like. I'm going to have my intercept at negative 3. I have an asymptote at negative 2. I have an asymptote at positive 2. I've got a y-intercept at negative 3/4. Maybe it's around there somewhere. I've got a horizontal asymptote at y equals 0. And now I got to sketch my graph. So this is really interesting because I have a horizontal asymptote of y equals 0, and I'm negative up to where x is equal to negative 3. So my graph is going like this, but then it has to, whoa, cross the asymptote. Wait a minute, is that allowed? Yes, it is. You're allowed to cross a horizontal asymptote because remember, the horizontal asymptote is what happens at its end behavior. If you go really, really far out on this graph looks like the line y equals 0. But inside, close to where all the action's happening, we could cross that asymptote. That's pretty wild. And then let's see, that makes sense between negative 3 and negative 2, it's positive. From negative 2 to positive 2, though, I'm negative. So I got to follow the asymptote, go through the intercept, follow the asymptote. Wild stuff. And then outside of x equals 2, I'm going to go here. That's pretty cool.